Okay. Hello everyone. I am Tarun, escalation engineer with Open Specification Support team. And in this session, I'm going to cover test suite debugging, taking from model and test suite. So, and the agenda of this session will be to debug test suite, to change variable values at runtime, and to integrate and make modification in protocol stack SDK. So for this demo purpose, I have considered NRPC test suite, and this is a sample scenario that will try to debug and make changes to see, how model integrates with adapter, and how we generate test cases, and how we interpret logs and all other stuff. So the scenario is pretty simple. It has 4 exchanges. The first exchange is that a protocol client send a challenge request to a domain controller, receives a response, then a protocol client sends authenticate 3 requests and receives a authenticate 3 response, and the secure channel will be established. The two requirements here are that this request should go before this, and the target server should always be a domain controller. This API is not supported on a domain member. And I'll try to show this in model. I'll make changes at runtime in model and show how easy it is to generate test cases and to test it. These are main key scenarios that I will cover in demo. Like first one is test case execution options. There are 2 options: either execute test cases from command line or from a Visual Studio. The other is how to modify an existing test case. Sergey already covered most of this stuff, but if you want, there are some MSDN references where you can go and learn how to make changes in model, and then how to change values at runtime in adapter, how to debug stack code using symbols, because the way we have made our test suites are that the protocol stack SDK is not integrated as a part of our test suites. We do use libraries from protocol stack SDK, but it's not integrated. So when it comes to debugging, you can debug a test suite, but not protocol stack SDK. When the call goes into a protocol stack SDK, you cannot debug it unless you specify a symbols, or you hook the code, or you integrate the stack SDK code with test suite. So I'll give a demo on that. This is using symbols, and this is the last one is how to integrate stack code with test suite, so that it's easy for you to debug even the stack code also. So I'll directly jump to demos now. So this is my test environment right now. I have a client that has a test suite installed. Then I have a bunch of servers. One is domain controller, one is trusted domain controller, and one is member server. So I log into this where this VM where my test suite is installed, and this is how a journal test suite looks like. Let me collapse this. So primarily 3 modules. One is adapter, the other one is model, and the other one is test suite. If the test suite is not model based, then you won't see this module. So primarily it will be like adapter and test suite, if it's a traditional based test suite, not a model based test suite. And let me show you how to run a test case from a command line. So this is a batch file that we have, and if you look at this batch file, we have given us a test case name here that we want to execute, and we have specified the location of our test suite DLL that we want to invoke. So once we run this batch file, this DLL will be invoked and this test case will be executed. So let me show you this, and just to make sure things are going fine, I'll just run netmon also. In the meantime, I'll just show you this test case in Visual Studio also. So this is a test case If you want to execute that from Visual Studio, there's a solution file. If you launch that, and if you go to VSMDI file, you will see the similar test case out here also. So you have two options, either through command prompt or through Visual Studio. The benefit with Visual Studio is that you get more control as far as debugging is concerned, because from command line, it's more of a free run. You don't have any control. You cannot control each and every step and each and every API in the call. And with Visual Studio, you get that, power. Okay, so I'll apply filter. Okay, so now let me run this test case. And this test case is making two calls. One is challenge and other is authenticate 3. And I'm expecting a status success from the server. So this is, when you execute any test case from a command prompt, you will see this sort of log saying, okay, test case passed or failed, how many test cases you executed, and where is the log file for that. Just to match that with netmon trace. So if you see, we're getting a return as success out here. That's what we are expecting. Let me show you here. This is the success. I'll just stop this. Now let's go to the batch to the output log files to see what all information we have there. So just copy this. So by default, all these log files are TRX files. So by default, they open with Visual Studio. But if you don't have a Visual Studio installed, you can open this with Notepad. So right now I've configured this with Notepad. If you open this with Visual Studio, it looks like this. So you have this, and if you want to see the details, what happened in this test case, just say right click and say view test and details. And if you go down here, you will see all the console output here. Let me highlight the. So this is, we are making a request challenge call, and here we are making authenticate 3 call. We are expecting error success and we got error success. So this is how our test case passed. But if you want to open this with Notepad, you can do that. And so all these are values taken from PDF config file. So you can ignore all these values. Just come down and see the stack trace out here. So you'll see the similar information. If you see this, sorry, authenticate 3, yep. So you will see the similar information here, that we are expecting error success, we got error success. But the problem with, not the problem, the main issue with debugging through command prompt is that if you are using any dependent library, and if there's any error in that library, you won't get logs. The logs will not be outputted here. So the only thing is, go back in Visual Studio and debug each and every line and see, what that function is doing. It may be possible that, that function is written with compatible to Windows 2K R2, but your server is like Windows 2K3. So you have to go and make changes in that function to support Windows 2K3. So in that case, you need to have a source code. You need to compile from Visual Studio and you need to debug from Visual Studio. In that case, you will be requiring protocol stack SDK code also. I'll show what are the cases where we require protocol stack SDK code. So this is how logs look like, and so this is a TRX file. If you want more information, it's close. It's almost similar information. We generate few other log files like this sample debug log file, which has all the comment and all the entire information if you want to just see what happened in that run. And now if you want to execute the same test case from Visual Studio, it's simple. Let's open Visual Studio and go to double click on .vsmdi file, type the test case name here and just check it. If you don't check it, it will not get executed. And never say, never select all the test cases and execute it, because then it will execute all the test cases. Always select the test case, click on that. If you want to have a free run, just say free run. If you want to debug it, say I want to debug it. So in this case, let's debug it. I already have a breakpoint in this function, so it will hit breakpoint. So I already have a breakpoint set in Authenticate 3, and you can see how it hit breakpoint. If you want to proceed further, just say F10, F10, F10. If you don't want to step to each line, just say F5. Just say F5. Let it go. Okay, it passed. Okay, now I'll show you that in case your call is being made into a dependent stack SDK code, it will not be resolved right now. Let me show you a demo of that. Let me run this again. Let me say debug. And say F5 and try to debug this. Oh, no, sorry. So I have stack SDK hooked up. Give me a moment. So let me remove this. See, this time it didn't go into that call because we don't have a matching symbols, and we don't, that the tester doesn't know how to go into that call. So if something is happening in this function, you won't be able to debug it, and you won't be able to change it also unless you hook stack SDK code. So I'll give a demo, how to hook that, but let me proceed with other things first. So almost as far as logging is concerned, you get the same logging if you run from command prompt or from Visual Studio. And so right now our test case passed. Now let's try to fail this test case and see what sort of logging we get. So what I will do as a part of this test case, we use machine account password to calculate a key. If that machine account password is incorrect, the Authenticate 3 call will fail. So let me change the machine account password. And since I am making change in a PTF config file, the file that I opened it was a PTF config file. There's no need to recompile the code because all the values from a PTF config file are taken at runtime. So there's no need to compile the code again. So let me start netmon. And now I'm expecting this test case to fail. No, it should fail. Let me see. So let's debug why it's not failing. So, DC type client. Sorry, client name is this, and primary name is this. Yeah, it failed here. So maybe it's not taking the correct PTF config file, but let's see. So it failed saying, access is denied because we calculated a key with a wrong machine account password. That's why server said, okay, I didn't recognize that. Let's fail this call. So in this case, it's quite easy to find, why it failed. And if you go to NRPC specification and if you go to authenticate 3 call, you will see, in what cases, access denied can come. And one of the cases is that, if you specify the wrong or if the key is calculated wrong, server will say access denied. And that's the case here right now. And whenever you run this test, the test cases, we do maintain a sort of history out here that if you want to see what happened before this run, you can always see that. So these are 2 ways to run test cases. And let me go back to, okay. The other scenario is how to modify an existing test case. Assume, you already have a test case design in model and you want to change that because, maybe you want to design you want to extend a test suite right now and you want to test a particular scenario which is not there in test suite right now. So for that, because since it's a model-based test suite, you have to first go to model because model is generating test cases for us. Now you can write your own traditional test cases, but it's better to leverage model since the model is already integrated. So for that, you have to go to model module and you have to open a code file. So code file has a scenario described in code file saying, okay, I want to test this scenario, this call should be after this call, and it will generate test cases based on that. But if you see a code file, it doesn't have any rule saying, okay, this call should be before that call or this call should be before that call, because our protocol specification says that your request challenge should always be before authenticate 3. If you just call authenticate 3, that's not a valid call. So let's see what model will do if we just call authenticate 3. So this is an invalid sequence as per protocol specification. So let's hide this, or let's enable this. And in this case, we are calling authenticate 3 before request challenge. Let's try to explore this, what will happen as far as model is concerned. So in order to generate test cases or explore this scenario, what you have to do is note down this machine name, because we are using whatever machine we are using here, because it's test enabled false. In this case, it's test enables are true. So we'll go to this one and we'll search it. We'll go to Spec Explorer, Exploration Manager, and we say find this. And if you see, there's a test. The test enable flag here is true, so we can generate test cases from this. So let's explore this and see what will happen. Because right now model doesn't know anything about implementation, how server behaves. Everything is static out here. We are not sending a packet to server and we are not receiving any response from the server. Everything is static right now. So if you see this, now I'm getting some red spots here saying, okay, whatever you are trying to do, the protocol doesn't allow that. So our model will not generate test cases for that. Because, again, model takes input from protocol specifications. And if protocol specification says you cannot do this operation, our model will not allow that. But if you go back to code, there's no intelligence out there in the code that decides, okay, whether this sequence is valid or not. So the place you should look for this intelligence is not in code, but you will see all these CS files out here. And so we are doing a secure channel. So I'll go to this one. And if you go, because we are trying to execute authenticate 3, and authenticate 3 is saying, no, I cannot execute because I cannot traverse that path because model is not allowing me. So if in this case, if you go to authenticate 3 call, and generally all these restriction and constraints are imposed by using a special type called is true, condition is true. So what we are doing in this case, let me hide these things, right, more clear. So we have a condition here that says if the challenge table contains that pair, then only proceed. And that challenge table will be filled when we exchange, when we execute the request challenge API. And in this case, we never execute that API, so the model doesn't have any value in this call. So it will not allow us to proceed further. Let's see if I just hide this call, what will happen? So I just disable that call. So if you see this now, I change a model behavior. So model now allows me to generate test cases for this scenario. Though it's not a valid scenario, but I change a model behavior. But it's not as per specification. But you can do that. So it's so easy to change model behavior. In normal traditional case, if you have to do that, you have to you have to write a new traditional test case, and then you have to make some modifications in code and I'm not sure what all places will be included. But in this case, it's very simple. Just alter the model behavior, and your traversal will be changed. Now let's see if we keep this line, and let me try to explore this again. So it failed here on a red state. So if you click this red state, and so we are suspecting that entry client challenge, that this could be the reason why model is not allowing us to move forward, and it's client challenge table. So let's go to the model. Let's click here and see challenge table, and it says it's almost empty. There are no values in challenge table. So this way you can see, if you know about protocol, then you can go and see in model, okay, what could be the reason why this call is blocked, why model doesn't allow that. Is it that there's some issue with the model, or is there some issue with the specification? Because it could be possible that specification does allow it, but somehow we coded it incorrectly in model. So you can see that redundancy out there, why it's not allowing that call and all those stuff. And till now, everything is abstract. We never ran this test case. We never tested, how server is behaving, what values we are getting from server. But as far as static check is concerned, we are making sure that whatever test case model will generate, it should be in sync with specification. Okay. Now I'll go back and change this call. I'll just disable this call, and let me go here. And in order to generate test cases, so till now we just did exploration. We never ran this test case. So in order, as Sergey was saying, in order to generate a test case, you have a button. So, and the button is this one. You say, okay, generate test code for me now. So it will generate a test code, and once you run that test code, it will test, at runtime whether I am getting the correct value from the server or not. So a new test case got generated, a new test case file got generated, and if you go to VSMD file, it will say, changes were made to the test, just do a refresh. And in order to do refresh, you just say, okay, refresh. So it will load the file again. And the way we do it, the file will be attached here, and each test case has a attribute saying, okay, this is a test attribute or this is a test case. That's why, our VSMDI file is able to do that, is able to read that. That's a valid test case. Okay, and the other thing is, let me go back to model. So if you see these calls, all these calls are abstract calls. We never pass a real value. Just to take an example, if you take this call, we just say, okay, target primary DC. We never provided any credentials. We never provided any IP. We never provided any hostname for this. So how this is getting converted into a real parameter? So I'll show you that how we convert abstract parameter into a real parameter. But just to let you know, model always provide abstract parameters. It never provides real parameters. So let's debug this test case and see how these values are getting changed. So I'll take this one. I'll say, let me go to authenticate 3. So model always makes a call to adapter. So if you want to debug any call, you have to go to adapter, because model generated test cases, but those test cases will make a call to adapter. So let me show you. If you go to adapter and if you search for, I think I'm already in that function. If you go to this function, you will see that we are receiving only abstract parameters. So let's put a debugger here and see how this translation is going, how these abstract parameters are converted into real parameters. So let's debug this. Okay, so we received an input parameter called primary DC type, and we are passing that to this function to get the real attributes. So let's debug this. So it says, okay, if you get this value, primary DC, you pick this value. Now, from where this value is coming? This value is coming from PTF config file. Let me show you this value in PTF config file. Let's go to View, Solution Explorer. So here is that value. So this is how we are changing abstract parameter to a real parameter. And since all these values are picked at runtime, that's why I told earlier, that if you make any change in this PTF config file, you don't need to compile the code again, because all the values will be taken at runtime. So if you make any change on this, if you execute this test, if you execute your test case, the values will be different in your code. I can show you the example. If I just change this, maybe, yep, no, it will fail me. I'll not change this, but let me see what all attributes are there. Okay, let me change account name. Okay, let me change account name to 222. I'll just say stop debugging. Say debug. So if you see, Visual Studio didn't compile the code again. So see, we got that changed value now, endpoint 01222. So this is how we change values, and that's the reason. All the values that will be changed based on the setup or environment, like you have a non-Windows server, or you want to include more servers, all these values are kept in PTF config file so that you can change it and there is no need to compile code again. Okay, let me go back. So now let's see, because we have an incorrect value in PTF config file, we know test case will fail, but we don't want test case to fail because it may happen that you don't know from where that value is coming. It's hard to find, but you want to just override that value. So let's see how to override that value. So I'll go back to this function. I'll say, okay, debug it. And this power of overwriting the values you will not get through command prompt. You need to have a source and you need to open that Visual Studio to make changes. Okay, so we are here and we know that we change value of account name. So let me put a breakpoint here and say, and hit F5. Okay, so now we have account name and we know this value is incorrect and we want to change it. So let's say quick watch, let us bring it back, dollar we need. So if you see account name, we change that value. Just hit F5. It failed because of access denied, because I changed password, and let me go back and bring it back. So let me replace this. The problem with changing values at runtime is that whenever you execute that test case, you have to make that change. You always have to step in and make that change. It's not like a static change. So if you are running a test case, if you are hitting same function 20 times, then you have to step in 20 times and change that value. So it passed this time because password was wrong previous time. Okay, so I covered how to modify an existing test case and how to change values at runtime. Now I'll go how to debug stack SDK code. The first option is, like, if you are not interested in changing any values in stack SDK code, you just want to see what that function is doing. The easiest way is you load symbol files, whatever we give you, and whenever you install a test suite, you by default when the MSI install all the PDBs of libraries into program files. I'll show you where it is. So by default, go to program files, stack library and bin. You just copy this value and you go to tools, options, and you say, okay, under debugging, under symbols, you have to give this path. And now let's try to debug this call, because this call is going into stack SDK code. So until unless you specify symbols, you won't be able to debug it. So let's debug this. Okay, so we are not interested in this call. I'll just remove. Okay, debugger from here. Okay, so now we want to step in. For that, you need to press F11, and we'll say, okay, do you want to step in? We'll say yes, and it will take me to that call. So you can see, what all magic we are doing into this function. But if you want to change anything in this function, yeah, you can change at runtime. But if you want to make any persistent change, you cannot do that. For that, you need to have a Stack SDK code, and you have to hook that or integrate that with Test Suite. So the only benefit you are getting is that you can see what we are doing in these calls. That's it. And if you want, you can change things at runtime. That's it. So I'll just say, let me fix this thing also. So if you don't specify this setting, then you won't be able to go into that function. See, we're not able to go into that function. Let's just say stop debugging. Now the time-consuming part. If you want to integrate Stack SDK code with this test suite, what all changes you have to make? Why I want to integrate Stack SDK code is because if you see all this reference libraries that we have added, any call going into this reference library, you won't be able to make any changes. For that, you need to get Stack SDK code and you need to integrate it. So the steps for that is, and more or less all these steps are applicable to both Exchange test suites and Windows test suites. Like they are generic. So you have a folder called Proto SDK, and since this is NRPC test suite, you say, and you open this solution. So this solution is different from our test suite solution. Let me collapse all these. So these are various modules that NRPC is using, and like we can use PAG. NRPC can use PAG. Then we can use Kerberos. Then we are making some file access services, calls SMB, SMB2. So now we want to compile this, and we want to take the output libraries, and we have to integrate that with test suite. So let's first compile this. Just still building it. So rebuild succeeded. So let's go to this folder. It's under NRPC bin debug. If you want, you can change this folder location, but in that case, like if it's hard to remember where it's going, not sure why it's so slow today. Okay, so you go to build and you have to specify path here like C debug or D debug, wherever you want to dump files, the output files, you can give path here, but this change you have to make for all these modules. So right now it's by default it's going in this folder. Okay, so I have all the libraries, I have matching, PDBs also. So let's take this. And right now if you see in this properties, from where this DLL is coming, let me expand this. So right now it's coming from program files and I want to change it. So what I will do now is, let's remove it one by one. Let's start from test suite. So all this stack SDK, we have to remove all these components. So it's stack SDK, NRPC, SSPI, just remove these. And say add reference. So we have SSPI, NRPC, and the other one was stack SDK, right? So add these three DLLs from different place now. So we made change in test suite. Now made changes in similar change in model also. Make sure you give correct path here. Okay, so we change this and the last one. So we have a couple of modules here. So let's change them. Okay, in a set of 3: transport, SSP, SMR. Let's change it to transport, SSP, SMR. NRPC and LMP RPC. So after changing all these dependent libraries, you have to compile it. Let me remove this path if it's already there. It's not there. Okay. So build succeeded. Now let's try to debug this test case. Okay, so call came here. Let's try to debug. And let's see where this file is now, where this file is coming from. So if you say open containing folder, it's coming from our solution that we have, because since we changes the reference libraries, now it's taking us to our source code now, the dependent stack SDK source code. So let's say, now if you want to make any change out here, like Now you will see as soon as I make changes here, it will get reflected to my other solution. Let me stop debugging. Okay, that file is not open right now. See, the change will come here now. So whatever change you will make in Stack SDK, like it's vice versa also. If you make any change in Stack SDK, it will get reflected in Test Suite. If you make any change in Test Suite, it will be reflected in Stack SDK. But keep in mind, if you make any change in Stack SDK code, and if you compile only Test Suite, that change will never come. Because what you have to do is these are totally different modules. So what you have to do is if you're going from a Test Suite to a Stack SDK, and if you want to make any change in Stack SDK like this, so if you compile Test Suite, that dependent library will not get compiled because it doesn't have a source code for that. It doesn't have any way to know, okay, I have to compile that because there is no dependency set as such. So what you have to do is you have to go back to Stack SDK. Okay, it got changed, and you have to compile it from here. Now see, if you clean this solution right now, like if you are removing all the dependent libraries, see, you will get yellow mark here because now those libraries doesn't exist because there's a linking between these two. So what you have to do is you don't have to link it again, but you have to just compile it. You just say, okay, rebuild. So once this is complete, you will see that all the yellow marks from the Test Suite will go off. Still building. So, yep. See, all those yellow marks will just disappear. So just make a note that if you change anything in Stack SDK, do compile it, or the changes will not get reflected. Now there are ways to control logging. As Sajid said, we have this beacon logging concept. Assuming you are running, like maybe 10 test cases, and you don't know, like, because if you run 10 test cases, if you want to analyze netmon traces, you don't know, which particular traffic is relevant for this test case, and which other traffic is relevant or related to other test cases. So we sort of have a beacon logging concept, and the way you can control that, I'll show you what beacon logging is, but the way you control that is through this PDF config file. And if you see here beacon logging, if you remove this sync from here, and if you remove all these things from here, then beacon logging will not happen. Now I'll show you what beacon logging means. So let's run our test case. Because if you run number of test cases, you need a mechanism to segregate, okay, this traffic is only for this test case in order to debug it. So we'll run the same test case, and we'll start netmon also. And we will apply a filter called tsap, which is for beacon logging. Now let's run this test case. It's taking time, but I think it has done its work. Yeah, it's stuck, but I can see traffic here. So if you go back, so we are executing this test case, and the name of test case is server authenticate 3s2. So if you go back to netmon trace, let me extend this. So this is the test case that we are running right now. So if you have beacon logging enabled, and maybe for any reason that particular test case is failing, like you initiate a test run like maybe early morning, and then few of the test cases failed, then you can see okay, this test case failed. So what happened for this test case? So just if you come down, you will see protocol traffic out here, and you can analyze, okay, for this test case I sent this request with these parameters, and server just maybe access denied, or maybe server passed that request. So that way it's quite easy for you to see okay, for this test case what all are the protocol packets that can help me see why this test case failed. I'll just stop this, and if you don't want this, just say.
What exactly does this put comment?
Yeah, it put comments, it put status there, whether test case passed or failed. It's a sort of a beacon packet. We just broadcast it, and we say, okay, no.
Extra packet goes.
Yes.
But the actual protocol packet is not ordered.
No. So it's a sort of extra packet that we send, the test suite send, to just delimit saying, okay, no, this is our packet, and this is our test case packet, and that's other test case packet. So it doesn't impact, protocol packet at all. This is our custom, you can say, protocol. So if you want to just see NRPC, you can just remove that filter. It's a bit chatty, so so that's pretty much as far as debugging is concerned. If you have any queries or questions, please go ahead.
I just wanted to know where. I just wanted to know where you associate the specification with the tests, or the test suite that it's supposed to generate for.
Where we associate.
MSNRPC.
So I didn't get where we associate means.
So you can associate a specification that you want to generate test suites for.
Yeah.
And then you showed that if you changed it, if you incorrectly set it, then it didn't generate the test suites, right?
Yeah.
Because it was using the specification to validate. Where do you specify that specification?
So it's like we have modeled this, so it's not that when we make changes in model, it is going to specification and reading stuff. It's not like that. We read specification manually, okay, and we coded something in model. So if something changes in specification, it's not that the model will pick that at runtime or compile time. No, we have to go back and make changes in model. Just to give a normal example, that we wrote model, and at that time the specification was updated only till 2K-R2. Now WinRT is there, so it's not that the model will pick what all changes are there in specification from the document. No, we have to go back and make modifications in model. So that's not an automatic process. Go ahead. Yeah, he might shed more light on that.
Yeah, I think mostly as Tarun said, but just one thing to add is that actually there's one thing which flows through the specification to the test case execution and also to the log is the requirements, right?
Yeah.
Because we are encoding the requirements into the model, and then the requirements are generated into test code, and finally they're dumped into the test execution log. So finally, you can, by reading the log or by, I think also by reading the beacon package in the ML, you can see what kind of requirements in the specification have been covered during the test execution. Yeah. Just
Let me show you that how we relate.
While Tarun is looking for that, I will also say we have all of this reference information for you. For example, as Tarun mentioned, we have already tested NRPC for Windows 7 and Windows Server 2008 R2. The test suite for MSNRPC is provided you at our applied interoperability website we showed earlier. So that test suite is available for download. Along with the test suite, there's several very useful artifacts. You may mention that we've got a requirement specification. All the requirements derived from the specification itself. And those are the ones that Tarun was utilizing or referring to. They are listed in the spreadsheet, which also Serge mentioned earlier. That spreadsheet's included along with the test suite. So we have also got a design specification, which describes the overall scenarios that we use to test it and to test those requirements. So you can refer to those artifacts or reference documents along with the test suite that we've posted to the Applied Interoperability website. So hopefully that'll be helpful to you.
And if you see our logs right now, so we have this checkpoint saying, okay, requirement 15, R18, and all those stuff. So what we do is, we take specification and we derive, a requirement specification from that, and that requirement specification will have this requirement tag saying, okay, this is a requirement 15, 8, 9, 10, 11, 12, 13, and all other things. So whenever requirement fails, okay, so we'll go back and check, okay, this requirement failed, requirement 180 failed, go back to requirement specification and check what is 180. So 180 will say, okay, authenticate 3 should not be called before, or maybe there's some sort of hints there saying, okay, this call cannot be made before this call. So that way you track, okay, I am making a mistake, model did allow me, that was correct, but now I'm making a mistake and this requirement is failing. So which specification, which section in MSNRPC specification this requirement is given. So that way you can track, okay, this requirement failed, where is this requirement, go back to requirement specification, and from requirement specification, you will get a section number saying, okay, this is a section in document where this requirement is mentioned, and that's why the test case is failing. So you can,
You'll actually see more of those practical scenarios in the test suite specific presentations.
No, so what I'm saying is you can actually see some of those practical examples, right, in the test suite demonstrations that are going to happen tomorrow and after. So they'll actually run through the test suite and show you how to basically track and trace a requirement from the output through the test suite to the document, right? And all the end-to-end scenarios and all that.
And again, we will be posting the sessions from this presentation, but all of our previous Plugfest events, when you go to the Channel 9 website from MSDN, you can download any of the presentations on any of our test suites, from NRPC to SMB to Kerberos, the Kyle and Pack, to other ones, and you can see how what Maruti described there will be examples and others provided for each of those test suites.
Let me show a glimpse of requirement specification. So this is how the requirement specification will look like. So you have requirements saying 1, 2, 3, and we have tons of requirement in RPC, and you have a section number, and then you have a description that all this is extracted from the document itself, and then you have various other fields out there. So if your requirement 2 fails, you will get a log there saying requirement 2 failed. Come back to requirement specific and see why it failed. What was the requirement actually? Like requirement will be logged there, but I don't think the section number will be logged there. So you come here, you take the section number, and then go back to the specification and go to the section number and see, okay, this is what we are doing wrong. That's why the test case is failing. So you can relate things, based on that. Any other question? I think we're good. Thanks a lot.